new light, one that's more intense and focused. The source of this light is an electrified filament of wire, and assembling that filament in the bulb is a very delicate task that's performed entirely by machines. Production now focuses on the glass tube that will serve as the mount for the filament and its electrical contacts. Machinery inserts 2 copper wires into each tube. These are the lead wires that will eventually connect the base of the bulb to the filament and deliver the electric current. These long glass tubes will be used to suck air out of the light bulb, preventing oxygen from reaching the filament and destroying it. They protrude from the glass mount, but that's just temporary. They will later be cut shorter. Torches now melt the glass mount, lead wires, and exhaust tube together. Mechanized fingers then pinch the layers together, and the wires are now encased in glass, but protrude from the glass base. Grippers transfer the closed mounts to a carousel. It revolves to allow the mounts to receive a coil made of tungsten metal. This coil is the filament of the reflector light bulb. Mechanized fingers attach the small coil to hooks on the 2 lead wires. The coiled filament is wobbly, so next it gets some support. First, machinery bends the lead wires to move them and the filament out of the way. Then, a robot presses the tip of the glass exhaust tube onto a burner. The tip melts, allowing a metal support wire to be embedded into it. Another robot bends the lead wires to position the filament adjacent to the support wire. The next station loops the wire around the filament. This gives the filament the necessary support, and it stops wobbling. This 2-pronged device then straightens out the lead wires. The mount is now upright and riding another carousel. Flippers set it straight, so a metal disc can be installed on the pinched section of the mount. This disc is reflective. It will bounce light downward to the shiny coating inside the light bulb to create just the right effect. With the disc wrapped around it, the assembly is now positioned on the next turntable. Suction cups deposit the glass envelope on the assembly to encase the filament and reflective disc inside. The holder twirls the bulb as it travels past a row of torches. The flames melt the neck of the glass envelope, and it closes around the glass mount. This secures the filament, contacts, and reflective disc inside the bulb. Another set of torches, heated to a much higher temperature, trim the base of the bulb. Molding devices now move in to shape the bottom of the bulb so a metal base can be fitted to it. A gripper then puts that metal base on a track to meet up with the reflector light bulb. By now, the bulb has been flushed of oxygen and filled with argon gas so it will last longer. The metal base finishes it off and will allow the bulb to be screwed into a light fixture. Another flame heats the metal base to cure adhesive that was pre-applied for a strong bond to the bulb. Then, robots cut off protruding wire and form a contact on the base. It has taken just 12 minutes to assemble this reflector light bulb, but it will provide about 2,000 hours of light.